will analyze the simple SSL handshake protocol. So as we know that if you are going to use any of the protocol, because this protocols you are using for which purpose, to establish the secure network channel. So that's why you have to analyze that whether it is secured or not here. Okay. So that thing only we call as the analysis. The simple SSL handshake protocol achieves its three main goals. So if it achieves these three main goals, then you can analyze that whether it is there or not. Based on that, you will decide whether you are going to use this handshake protocol or not. Agreement of cryptographic algorithms, entity authentication of the server, key establishment. So these are the three main goals, whatever it is required to achieve. Okay, that is which type of the cryptographic algorithms you are going to use, okay, and what entity authentication of the server to prove, and key establishment here. So SSL handshake protocol with the client authentication data, SSL record protocol here. So now here thing is what it is, handshake protocol with the client authentication. Client authentication is also very important. Next is the client authentication data. So here this client authentication is the identification of the client, and what are the data it is sent by the client. No, for that data also you require the authentication. And SSL, next you will learn about the SSL record protocol here. In particular, the following four symmetric keys are extracted from the key block in the key establishment. So symmetric keys, okay, it is extracted from these four blocks. First one is KECS for symmetric encryption from the client to the server. So client to the server, if you want to make the encryption, then it is you are using as a KECS, key establishment for the client to server. So next is key establishment SC, server to client, for symmetric encryption from the server to the client here. Okay. Next you are using one more key, that is the key message authentication code CS from MAX, from the client to server, and KMSC for MAX from the server to the client here. So these are the keys you are going to use. Okay. For which purpose? For encryption purpose and for MAC verification here. So these are the keys you are using. From client to server if you are using, then you are using CS, and from server to client if you are using, that is you are using the SC here. Here is one example. If you want, okay, client want to send the data here, what procedure it has to follow. So first it has to procedure follow is what it is. First you have to compute a MAC on the data. So using key KMCS, okay, KMCS is the key. With the help of this key, if client want to send the data to the server, first it has to compute the message authentication code on that data. So for that you are using which key here? You are using the KMCS key. Later you append this MAC to the data and then pad if necessary to a multiple of the block length. If you are using the fixed block length, then what data you want to send. So for that data, now you have to add this message authentication code, which one you are calculated with the help of this KMCS, and later if it is okay fixed length, if it is there, then you can pad with the zeros here. Next, what are the result you will get? No, that message, that one you are encrypting using KECS. Client will encrypt that message. That message contains what it is? MAC plus data plus padding value. Okay, upon receipt of the protected message, the server decrypts it using what? It decrypts using the KECS and then verify the record MAC using the KMCS. Okay. So now here this is the message is sent by the client. So whenever it is received by the server, server will decrypt and it verify the message authentication code. Now here question is how to manage the keys, and as we know that in cryptography you are using the two types of the keys, public key and the symmetric key. So now based on that you are manage the keys here. So essentially it relies on two separate key manager system, because you know that in cryptography it supports two type of the methods, public and the symmetric. So that's why Here in SSL if you are using, so you need to provide the different types of the key management system. Public key management system, so here you are going to manage both public and the private key. And symmetric key management system, you are going to manage only single key. And one thing you remember, the symmetric key management is you have to manage very securely here, because same key you are using for encryption and decryption. So that's why you have to share this key very securely. Whereas in public key management system, public key you can share publicly, where private key it is there with that particular receiver here. Okay. So now here based on that you are using the key generation methods. There are two types of the keys deployed in SSL based on this key management. So you are deriving the two types of the keys, that is asymmetric keys and symmetric keys. So asymmetric keys we call as a asymmetric. Even public key, that one you are using one more word as a asymmetric key management. For that you require the asymmetric keys, and for symmetric you require the symmetric keys here. So now once if you are develop the key, after developing those keys, next question is what you have to make the key management. Key management contains what? Key establishment, key storage and key usage. In the fourth model you already learned that what are the methods you are going to use and how to establish and how to store the keys and how to use the key usage. With the help of those things, here you are established the keys once if it is keys developed. So next, as you know that, so that keys also you have to store securely. For storing that you are taking the key storage and key usage. Which purpose you are going to use that particular key, that one also very important here. So security, what are, okay, these are the things even in the SSL, okay, SSL protocol you are using for making communication or to establish the secure channel. So these are the procedure it has to be followed here, okay. So after following that also you may face the issues. What are those issues? Let's see. SSL security issues, process failures, implementation failures, key management failures, usage failures. These are the four different security issues comes under in this SSL. Okay. So SSL design issues. Okay, first one is support for a range of publicly known as cryptographic algorithm, because flexibility, minimal use of public key operations, unbalanced computational requirements. So design issues, you already know that these are the failures because of which reason? Process failures, implementation failures, key management failures and usage failures, or due to the reason of what it is, publicly known cryptographic algorithms, because the same cryptographic algorithms is known by everyone. So whatever it is supported by this SSL, SSL supporting algorithms are known by everyone publicly. Okay, everything is known that what type of the cryptographic algorithms this particular SSL protocol supports. Flexibility here, okay, it is flexible, due to that reason also it is the problem here. And minimal use of public key operations, here you are going to use the public key operations are very minimal here, okay. And unbalanced computational requirement, so unbalanced computational requirement is also one of the designing issue of SSL protocol. So this is about your, okay, this SSL protocol you are using in which application? So if you want to use for the internet, in the internet if you want a cryptography for the internet, it is possible with the help of this SSL protocol here. So if you are going to use this SSL protocol, this is the information related to SSL protocol.